Hello and welcome to another mathematical studies video. We keep talking about the chi-squared statistic. So you remember our example. We had this dice, we were rolling it, and we calculated this chi-squared thing that told us how far our observations were from our expectations. So I have these results here, and I would calculate the chi-squared using this formula, and I would get that it was 3.2. Now here's the problem. What does 3.2 mean? I mean, does it mean that it was far, or does it mean that it was close? We need something to compare. So chi-squared equals 3.2. Is it good or bad? We use something called the critical value to compare it with. And what's going to happen with the critical value is that if chi-squared is bigger than the critical value, we say that it's too far from the expectations. Hence, if that happens with the dice, I would say that the dice is biased, that something is wrong with the dice because it's too far from the expectations and something is fishy. On the other hand, if chi-squared is smaller than the critical value, it's close enough to expectations and it's fine. It's just a normal kind of disparity there is between what we expect and what we get. So how do we figure out this critical value? Now this is important. To calculate it, normally written like that, they're going to give it to us. We don't have to calculate the critical value. The IB will give it to us in the exam paper. However, they do expect us to understand where it comes from. And the place where the critical value comes from, it comes from two things. On the one hand, we're going to have the significance level, and on the other hand, we're going to have the degrees of freedom. Now, you don't need to know how to calculate the critical value, but you need to know how to know the degrees of freedom on a particular situation and what the significance level means. So let me explain first the degrees of freedom and then the significance level. For example, the degrees of freedom, where do they come from? Now, we had the example where the dice was thrown 60 times and we were recording the observed results like this. Now, suppose that you see this table and you see it this way. Now, you know that Dave throws the dice 60 times. So this value here, you can calculate it easily. How? Well, it's going to be 12 because 60 minus 7 minus 11 minus 10 minus 7 minus 13 is going to give me 12. So the important thing to realize here is that as I put data in here, as I fill this data in, the moment that I put the fifth one, the sixth one is automatically determined. It's going to be a 12, nothing else. Now, I can freely put in 5 values. The sixth value is set at the moment the fifth one is. So that's why we say here that I have 5 degrees of freedom. The significance level is going to be, it's simply, in this case, 5%. This is how you write it, sorry. And it's going to just telling us how rigorous we're going to be. If I have a very high significance level, any little deviation is going to set the alarms off. If you have 10%, which is normally the highest you will ever find, if it's slightly off target, it's going to set the alarms off and say like, careful, but possible bias. If it's very low, like 1% or even 0.1%, it's going to require a big deviation from the expected value for it to be significant. So the lower the significance level is, the more exaggerated I need the results to be. So this significance level is setting the threshold at which we consider the distance between the expectations and observations to be too high. In the example, we have 5 degrees of freedom. So here are going to be the critical values with a 5% significance level and 5 degrees of freedom. So remember, the critical value is set by degrees of freedom and significance level. So if it's 10%, it's going to be 9.236. If it's 5%, 11.07. And if it's 1%, 15.086. Now, understand that I would need to have a very high chi-squared to be over 15.086. The results would have to be really far from the expected values. So here's my example again. Do you remember how we calculated the chi-squared for 2 more die? Well, let's look at the 3 dices all together. The first one, and we're going to look at 5 degrees of freedom with 10%, 5%, and 1%. So here's the first die. 7, 11, 10, 7, 13, 12, more or less relatively close. The chi-squared, sorry, this is dice 2, and this is dice 3. Now the chi-squared in the first one is 3.2. So this is smaller than all the critical values. The dice is not biased. I would need to have a very, very, very high level of significance for 3.2 to be bigger than that. But 3.2 is smaller than this, and smaller than this. Hence, we can pretty safely say that the dice is not biased. But look at dice 2. Now here the chi-square is 14.4. So with a level of significance of 10% or 5%, the die would come as biased. If it was a little, like it's not enough for a 1% level of significance. And here we have dice 3, which is going to be over my level of significance 10%, over the critical value for 10%, and under the critical value for 5%. So in essence, we need the critical value to compare it with, but it's going to be determined by the degrees of freedom and the level of significance, which is just how rigorous I'm going to be. Thank you for watching. See you in the next one. Bye.